Hello, we're going to look at example 36, and it says that to show that when you take the cross products of of two vectors, and that's equal to 0, then if and only if u and v are collinear. So the important thing to notice here is this if and only if. What does that mean? If you remember from a geometry class, conditional statements, we would write this like this as a conditional statement. And that means basically if this is true, that implies that's true. And also, if this is true, that also implies it. So you got to be able to show it both ways. So basically, I got to show that u cross product. If u cross product v is equal to 0, then that will imply that u and v are collinear, right? And if they're collinear, another way to write that is that basically either u is equal to some lambda times v or vice versa, right? And also, so once we start with this and we can show this, then we have to go the other way, right? If this is true, if this is collinear, these two are collinear, then we can show that the cross product is equal to 0 too. So we can say that's all true. So let's go ahead and get rid of this, give me some room, and then we're going to go ahead and start. So let's start with this guy here. If this is true, we're going to show that it is in fact collinear, right? So first we're going to assign vector u, right? Let's say vector u is going to be u sub 1I plus u sub 2j plus u sub 3k, right? And then if vector v is equal to v sub 1I plus v sub 2j plus v sub 3k, right? Then we can take the cross product u cross product v, and we can write this as the determinant is I, j, k, and we'd have u sub 1, u sub 2, v sub u sub 3, and then v sub 1, v sub 2, v sub 3. This discriminant would have to be equal to 0. Or it's another way of writing it. If it's equal to 0, we can write it like this, right? Then it's going to be equal to 0 is the same thing as the 0 vector, right? Good. Now we can go ahead and find its components by taking the cross product, right? And if we take the cross product, right, before I showed you put your hand over this and it would be u2 v3, so I'd have u2 v3 minus u3 v2. That would be equal to 0, right? That would be our I component, right, of the cross product, right? Our v component would be put our hand over here, and we'd have to take minus this times this, or we can switch the order. So it would be u3 v1 minus u3 v1, u1 v3. That would be equal to 0, right? And then the last one, to put your hand over this, and it'd be u1 v2. So u1 v2, u2 v1. And then what we can do then is we can go ahead and solve these, right? I can solve these first guys right here. And basically, if I solve this first one right here for u sub 2, or components of 2 and v sub 2, I can add this way and divide. And I can show that u sub 2 over v sub 2 in this first guy right here would be the same as u sub 3 over v sub 3, right? And then I could do the same for this guy right here. If I solve for u sub 3 over v of 3, that's going to be u sub 1 over v sub 1. And then finally, the last one right here, I can solve for if I solve for u sub 1, I'd have u sub 1 over v sub 1 equals u sub 2 over v sub 2. And what does this all mean? this means that I can take, they're all equal to each other, right? So I know that u sub 1 over v sub 1 is equal to u sub 2 over v sub 2, which is equal to u sub 3 over v sub 3, which is equal to some scalar lambda, and that's what it means to be collinear. So I can basically write all these ones. I can write u sub 1 is equal to lambda v sub 1. I can write u sub 2 is equal to lambda v sub 3, and I can write u sub 3 is equal to lambda v sub 3, right? And all this means it's collinear. So therefore, we know that vector u is equal to lambda times some vector, because the components of u are some constant times every component in this, therefore collinear. But there is a case here. This is the case where we're just assuming that these components, we are assuming that, you know, if all the components are 0. What if one of them was 0? So this was basically a first case that we identified. So what we're going to do now is we got to look at, well, so we'll go up here, what if v sub 1 is equal to 0? This only is true if all the components are non-zero. But let's assume that one of them is 0, right? If v sub 1 is 0, right, then I know that if I take this guy right here, v1 u3 is equal to u1 v3, then this is equal to 0, and then I know that u sub 1 is equal to 0, and I know that v sub 3 is equal to 0. So good. And then if v sub 1 is 0, here's my other one. I know that u sub 1 u sub 2, u sub 1 v sub 2 is equal to v1 u2. But I know v sub 1 is equal to 0, so I know that u sub 1, which we already said was 0, but v sub 2 is also 0. So what do I have right here? I know that I said v sub 1 is equal to 0. Then I showed that v sub 3 is 0, v sub 2 is 0. So that means my vector v is the 0 vector with component 0, 0, 0, right? And then we can do the same, right? Well, we know we've shown u sub 1 is 0, right? So we know u sub 1 is 0. If u sub 1 is 0, then I know that u sub 2 v sub 3 is 0 using this guy right here. Then if u sub 1 is 0, u sub 2 v sub 3, I'm sorry, that's v sub 1 is equal to 0. So that means u sub 2 is equal to 0, right? Good. And if u sub 1 is 0, and then I know that u sub 3, right? U sub 3 is also equal to 0. So now I know that vector u is also 0, 0, 0, right? Which these are obviously collinear for the same reason that we said right over here, right? U times b is this. It's just this. So we've shown in two cases, right? All non-zero. These are all collinear when they're non-zero. And if one component, all it takes is one component to 0, all the rest of the components are 0. Therefore, they're also collinear, right? So now we've shown this guy. We've shown that this guy implies this way. Now we got to go the other way, right? We got to start with the fact that they're collinear, right? So if they're collinear, let's do this. Now, so first we got to start with vector u. If vector u is collinear, then there's some lambda times b, right? So, and we need to show that if this is true between vector u, then the cross product times b is going to be equal to 0, right? So if this is true, right, then, well, we know that they are collinear, so this has to be true, right? So that means all its components, u sub 1 is equal to lambda v sub 1, then u sub 2 is equal to lambda v sub 2, and then u sub 3 is equal to lambda v sub 3, right? And then we can go ahead over here and then say, well, if we take cross product of these, right, then we'd have I, j, and then k, right? And then its component would be u sub 1, u sub 2, u sub 3, and then v sub 1, v sub 2, v sub 3, right? We're going to find out what this is equal to. But if u sub 1 is equal to, we can do substitution right here. So we're going to take the, this would be I, j, k, and then u sub 1 is lambda v sub 1, lambda v sub 2, lambda v sub 3, and then this guy right here just be v sub 1, v sub 2, v sub 3. And now we can find what this guy is equal to, right? So let's figure out what this is. So our I component would be lambda, the I component would be lambda v sub 2 times v sub 3 minus would be lambda v sub 3 v sub 2, and that would be my I component, plus, now the other one I do this way, so it'd be lambda v sub 3 v sub 3 v sub 1 minus lambda v sub 1 v sub 3 j, and then the last one would be lambda v sub 1 lambda v sub 1 v sub 2 minus lambda v sub 2 v sub 1. Okay, and look what happens. Lambda v sub 2 v sub 3, these are the same. This ends up being 0i plus these are the same. Lambda v sub 3 v sub 1, lambda v sub 1 v sub 3, that's 0j. And then the last one, these become 0 as well, so it's k, which is equal to 0. So therefore, we started with the fact that they're collinear, and then we were able to show that its cross product was 0, right? And there you go. So the recap, we were able to start with the fact that the cross product 0, that they factor in are collinear, and we're going to show when two cases, when the cases were all non-zero, that was this case right here. Then we show if one component is 0, and then it ends up being the 0 vectors, which are in fact collinear. So we showed it that way, and then we had to do if and only if. So then we had to start with it's collinear. So I went to this page, show that if this is collinear, right, we can make a the determinant of these vectors, the cross product of it comes out to the 0 vector, and there you go. Thanks, guys.